Power drills are pretty simple tools, but are you using yours correctly? And are you using it to its max potential? You might be surprised how often drills are misused. Getting hurt by a drill is possible and very painful. I know from experience. Not only that, but there are a lot of ways professionals use their drills that the average person might not be sure about or know about. Today, we're going to cover everything about using a drill correctly, from the different types to proper technique, and by the end, you'll have everything you need to know to use a drill like a pro. First of all, let's get familiar with the different types of drills. A drill driver is the simplest, and as the name suggests, these types of drills are used for drilling and driving. Drilling is using a bit to remove material, and driving is turning a fastener that pulls itself into material. Now, most drivers will have an adjustable chuck, allowing you to use a wide range of attachments and bits, and many drivers also have a clutch setting and a speed setting, which we'll get into later in the video. A hammer drill is essentially a drill driver that adds a function, the hammering function. This function is a pretty important one when drilling into stone or masonry. What hammer drills do is create a linear striking force on whatever you're trying to drill into, which helps break up hard materials and drill into these materials that you wouldn't be able to otherwise. Think of this like adding a jackhammer to the top of your driver. Hammer drills typically have the exact same features as a regular drill driver with the clutch and speed settings. But going with a hammer drill just comes at the expense of additional cost and a little extra weight. Now, a lot of drills come in a kit with an impact driver as well, so let's talk about that. Now, we've determined that drill drivers and hammer drills are pretty similar, they're like siblings. But when it comes to an impact driver, it's more like a cousin. You can see the resemblance, but there are major differences between these tools. For one, the impact driver doesn't have any gears, torque settings, or anything. Additionally, it restricts you to just using the 1/4-inch hexagonal bits rather than the adjustable chuck that you could put pretty much anything into it. This is because impact drivers produce more vibrations and higher torque than a driver would, which, if it had a chuck, it would lead to slipping. That being said, impact drivers are completely different tools with their own applications and nuances, so we're going to save that topic for another video. We're going to be using a hammer drill from here on out, since it pretty much has all the features of a drill driver with the added function of the hammer drill. Let's start by understanding the adjustable chuck. You can rotate the front of the drill to open or close this chuck, and you want to install any bit or tip here on the chuck. Next, you have the trigger, which as you pull it, the drill powers on. Now, most quality drills will have a variable trigger. This means that the drill speed will slow up or speed up the more or less you press on the trigger. Above the trigger, there's a switch. This lets us change the direction you're tightening or loosening the fastener. One side tightens and the other side loosens. You could also put this switch right in the middle, which will lock the drill and prevent it from powering on if you're throwing it in a toolbox or something else. Next, we have this switch on the top of the drill with a number. This is your gear or speed selector. This lets you choose between high speed or low speed settings. The high speed setting is faster, but it has less torque. And the low speed setting is, of course, slower, but it has significantly more torque. Some drills even have 3 settings for greater control. Hammer drills will typically have all these same functions of a drill driver with the addition of the hammer setting. If you want to engage the hammer function, you'll need to turn the collar to the hammer emblem. Activating this will engage the hammer and allow you to work with masonry. On this same collar, you have the clutch, which is a bunch of little numbers, and this is the least understood feature of a drill. The clutch on a drill is used to adjust the max torque you want to drill something or screw something in, and this can be useful for dialing in the depth you want to sink or drive a screw. It's particularly useful when maybe you're doing a lot of screws. To demonstrate this, we're going to put a screw in at every setting. We'll start with 1 and work our way up. As you can tell, as we increase the setting on the clutch, the screws are sunk more and more. And this comes in handy for repetitive situations where you may be installing hundreds of screws in drywall, for example, and you want them at the perfect depth every single time. It's also useful when working with small, delicate screws. In this case, if you over-tighten, you completely destroy the threads, rendering it useless. So putting a low setting can prevent you from damaging it. Next, let's cover properly drilling a hole. To do this, you first want to select the right drill bit. We're going to be using the basic fluted bit, but there are many different types of drill bits out there, and depending on what you're trying to do, there might be another bit better suited for you. If you want to know more about choosing the right bit, we have another video completely covering everything. Our first step is marking the center where we want to drill our hole. Additionally, depending on the size of the hole you're trying to drill, you want to secure that material down so it doesn't spin out of control. You also want to make sure that the backside of the workpiece is clear of any potential obstacles. You don't want to drill into electrical wires, countertops, or worse, your hand. So make sure your material is in a proper place where you won't damage anything underneath it. When installing your bit, make sure it goes in straight and is right in the center. The bit could grab before it's in the proper place, so make sure it's in the proper place. Now, as far as the speed setting goes, I will typically keep mine at high speed, but if you're just learning and you want to have a little bit more control, you can put that on low speed. In my case, I only go into low speed when the drill stops working or is binding in the material where I need more power. If you're drilling a hole, you want your clutch on the drilling setting. This is usually an emblem of a drill bit. When you're ready to start drilling, you want to set your drill bit on the center mark with the drill perpendicular to your workpiece. Then slowly start pulling the trigger and slowly drill into the material. Make sure it's right in the center, as drill bits can often walk on the material. If you notice the drill starts to walk off, stop the drill, reset it, and try again. You could also use a hole punch to get that started so the drill doesn't walk. As you're doing this, pay attention not to overheat your bit or your material. You might start noticing a burning smell or smoking from the drill bit. If you do, slow down or stop to let the bit cool down. When you're drilling metal, you always want to use lubricant. This will extend the life of your drill bits and prevent them from damage. As you're drilling, you also want to keep in mind chip ejection. You want to pull that drill bit out occasionally to make sure that the drill bit is ejecting all the chips. If you continue to drill without doing this, the drill might get clogged and it'll have a harder time moving forward in the material. Sometimes you'll even have to clear out those chips by hand. Once you're done drilling, be careful, the drill bit could be very hot, especially when drilling holes in metal. Now, it's worth mentioning that if you're drilling a very large hole, you're going to want to work your way up from a small hole to a larger hole, rather than trying to drill the large hole all at once. Now, it depends on the bit you're using, but working your way up will avoid the drill binding and it could save your wrist from a lot of trouble. Alright, let's move on to driving down a fastener. Now, when driving a screw, you could leave your drill as is with the clutch in the drilling position. You just want to be careful not to drive that screw in too deep. But if you're doing multiple screws, then you might want to adjust your clutch to the appropriate setting. If you're not sure what setting to set it to, you're going to want to start low and work your way up as needed. Now, if your drill is slipping, a good tip that I always use is to repeatedly stop and start the drill. As you're screwing something in, your tip can work itself out. However, if you stop, it allows the bit to fall back into its place as you continue, thus reducing the chances of camming out and damaging the head. If you're putting in a very large screw or you're putting a screw near the end of a wood grain, then you're going to want to drill a pilot hole. Pilot holes will avoid damaging the wood. To select the right drill bit, place them in line with one eye and select the bit that completely disappears behind the screw's minor diameter. With the right drill bit, you want to drill your hole to the proper depth, and then you can put your screw in without concerns of splitting. Now, drills may seem like simple tools, but they are hazardous if improperly used. Drills can bind and bite into material and cause you to lose control, commonly hurting your wrist. And this is probably the most common thing that happens with drills. Additionally, a common injury that can happen is coming into contact with either a drill tip or drill bit. If spinning fast enough or in the right position, it could cause a lot of damage. Now, if you want to avoid binding and hurting your wrist, you're going to want to work your way up with pilot holes. Drill a small hole and then work your way with larger and larger holes. There's also an option for a drill handle. Now, drill handles can get in the way, but they give you a lot more leverage and allow you to handle the drill with both hands, giving you a lot more strength and control, and preventing the drill from twisting and hurting you. Now, as far as coming into contact with the drill bit, you want to be careful. It's not a fun experience. I had a personal experience where I had to go to the emergency room and get stitches on my hand. Now, it was a particular case where I was reaming out a 3D printed part that I had made. Unfortunately, my hand got stuck in one of the flutes and it sheared off some of my skin. I was working on building a custom pocket hole jig with angled holes. With one hand, I was holding the part, and there was really no risk whatsoever of poking my hand with it. There was, however, another risk I failed to notice. As I was holding the part, my hand got into the position where the flute was able to pinch my hand with the material. So essentially, this was like bypass scissors cutting through my hand. I got my hand too close and the drill managed to snatch a little piece of me. It was not fun. I ended up having to go to the emergency room and get a couple of stitches. So be careful and be mindful where you put your hand and stay away from that drill bit once it's in motion. Lesson learned. The best option to avoid injuring yourself is to secure the piece somewhere where you don't have to hold it whatsoever. And this also goes for fasteners. For fasteners that are particularly long, if you go past something, you can end up puncturing yourself with a screw. So also be mindful of where you're screwing and how far it'll go. One final topic is choosing the right drill. If you already own a drill, is that the right drill for you? Or if you don't own a drill, which one should you buy? Now, the main factor is whether you buy a 12 volt or 20 volt, or whether you buy a drill driver or a hammer drill. Now, higher voltage typically offer more power output, but in my case, I find that the smaller drill is good enough for 99.9% of the jobs. The truth is, it's just always been enough, and I've never needed more power. The next point is whether to buy a drill driver or a hammer drill. If you have the money for it, always go for the impact driver. The impact driver just adds a feature, and why not? It could come in very useful if you ever need to drill into masonry, concrete, or whatever it might be. So if you can get it with the hammer drill function, I would go for that always. The next point is quality. Now, I am a believer in the buy once, cry once. Cheaper drills will usually sacrifice on features and general quality. So even if you're only going to be using your driver maybe once a month, I think it's worth it to invest in something decent. And that is everything you need to know to use a drill like a pro.